So our last topic in Unit 5 for 930 is we are going to talk about how to solve radical equations. So this is when you have a radical in your equation to start with. I know with Pythagorean theorem we used radicals in order to solve equations that had that squared exponent, but today it's going to be the flip of that. So what happens when there's a radical in your equation to start with? And when this happens, we do end up with some possibilities for answers to not actually work. So when you get an answer that doesn't actually work in the equation, we call that an extraneous solution. So we're going to talk about those as well and how to look for them. All right, so just as a warm-up, let's just kind of review the opposites here, our square roots and our squared. So go ahead and do these 4 problems as a warm-up. So the first one, remember that square root and squared cancel each other out, right? Square root of 3 squared is like the square root of 3 times the square root of 3, which would really give you the square root of 9, which really gives you 3, right? Square root of 9 is 3. So here, a square root and a squared are opposites. They cancel each other out. We don't have to show this stuff down here anymore because we know that those guys are opposites. They're inverse operations. So you don't need to show that part. Okay. So then the square root of x squared, right? Since we know that they're inverse operations, the square root of x squared would just give me x as my answer. Down at the bottom, just some review of negatives, right? Negative 4 squared is really negative 4 times negative 4. 2 negatives there, right? Negative times a negative is a positive 16. So just don't forget that. Those parentheses make a big difference. Now, number 4 might kind of be a review, but also kind of something new. Really, we're reviewing what a radical means, right? Remember that a square root means what number times itself equals negative 9, right? So what number times itself equals negative 9 is what the square root of negative 9 means. 3 times 3 equals positive 9. That's not it. Negative 3 times negative 3 equals positive 9, right? And I need to have a number times itself. I can't do, 3 times negative 3. That's not a number times itself. So you can't have the square root of a negative number. This would be a no solution. So here's where maybe you can start seeing how we might end up with some answers that don't actually work in the problem, because you cannot take the square root of a negative number. There is no number in the world, in the real world, where times itself will give you a negative answer, because anything times itself will give you a positive answer. All right, so those were a good review. So let's start looking at some actual equations that involve radicals, okay? So we're going to solve these equations, and the directions say, remember to check for extraneous solutions. So remember, extraneous solutions, these are going to be answers that we might get that don't actually work in the equation. And you might be wondering, what? How is that going to happen? And we'll talk about it, and we'll also see what to do, okay? So let's just start solving our equation over here and see if we encounter anything. So I have the square root of x minus 3 is outside the square root equals 4. Now I'm trying to isolate the x, right? I'm trying to get the x by itself. So I want to move things away from that x. I see the minus 3 right now. That's on the outside there that I could move right away. So I'm going to add, oh, not 4, sorry. I'm going to add 3 to both sides. That's more like it. To get rid of this number that's next to my x. So I have the square root of x equals 7. All right. Now, I have my square root of x is all by itself here, but I'm trying to solve for just x, so I need to undo that square root. So we just talked in our warm-up how square root and squareds are opposite, so we're going to square both sides in order to get rid of that square root. Okay, now back when we did Pythagorean theorem, you were given x squared and you had to square root both sides to get rid of it. So just remember, notice what you have in the problem and do the opposite operation to get rid of it. So in this case, it's going to be squaring both sides. So square root and squared cancel out. So I'm left with plain old x on the left. On the right, I have 7 squared, which gives me 49. I'm not sure why that's showing up down at the bottom. Sorry about that. Okay. All right, so x equals 49 would be our answer. Now, the only thing is we need to make sure that that number actually works in the equation. And so in order to do that, we actually have to check our work, right? Now, you guys are you used to do this all the time, probably back a couple of years ago, where anytime you got an answer, you would plug it back into your equation to see if it worked. And we haven't really been making you do that too much this year because usually, unless you made a mistake in your actual arithmetic, right, your answers would work. But when we have a square root like this, there are situations where you could do everything right and that answer just doesn't work in your equation because there are some things that you can't take the square root of. So we actually have to show our work for checking every single answer on every problem that involves a square root. So I would say I have the square root of x, which we now know is 49. So I plug in the 49 in for x. The rest of my equation says minus 3 equals 4. So I'm taking this original equation, square root of x minus 3 equals 4, and I'm plugging in the 49 in for x. Now, don't solve this. Don't move the 3 and do every single thing exactly how you did before. That's not the point, is to resolve it twice. Now what I want to do is I want to use my order of operations and just see if the left side equals the right side, okay? So square root of 49 would be the thing that I do next. Square root of 49 is 7. So I'll have 7 minus 3 equals 4. 7 minus 3 is 4. So I have 4 equals 4, which means, yes, this solution is an answer. So I could box it in that x equals 49 is my answer. So please just remember when you're checking your solutions, plug into the original equation and use order of operations. To see if the left equals the right, okay? Don't resolve the equation. All right, so that's the idea, right? Is to get that square root by itself, square both sides to undo that square root, and then make sure that you plug your answer back into the original equation to make sure it works. That's what we mean by checking for extraneous solutions. All right, here's number 2. So notice on number 2 here, I have the square root of x minus 3 equals 4. Now, look at the last one. This is almost exactly the same, right? What's the only difference between these two problems? Well, in the first problem, the minus 3 was on the outside of the radical. On the second problem, the minus 3 is on the inside of the radical. I can't move that 3 right away because it's locked into the radical. So I can't get it out of there until I get rid of the radical. So be very careful as you're writing these equations down and you're doing your work. Watch where that radical ends because it makes a huge difference. Is the number on the outside or is it on the inside? If it's on the inside of the radical, you can't move it until you get rid of the radical. If it's on the outside, you have to move it first before you get rid of the radical. So in number 2 here, I can't move that 3 right away. My radical is all by itself. So the only thing that I can do is to get rid of that radical right away by squaring both sides as my first step. And again, that's because all of the things are inside the radical on that side. So I can't move anything until I get rid of that radical. All right, so square root and squared cancel each other out. So that means I'm left with x minus 3 on the left-hand side. On the right, I get 4 squared, which is 16. Okay, now be careful here. This is an expression on the inside of my radical, this whole thing, right? It's not a negative 3. It's some number minus 3. So I'm not taking the square root of a negative number necessarily. If x is bigger than 3, that number is not negative at all, right? So when you do this, don't think that that's a negative number inside a radical until you're checking your answer. Okay. So I have x minus 3 equals 16. Now I can move that 3 to get x by itself. So I get x equals 19. Now remember, we need to check for extraneous solutions, right? So before I box my answer in, I need to show the work to check it. So in my original equation here, I had the square root of x minus 3, all on the inside, equals 4. And I'm plugging in the number 19 in for x. Right? Okay, so now I'm doing order of operations. I'm not going to solve it. I'm not going to undo that square root. What I'm going to do is this work inside my square root first. So I'm going to do 19 minus 3. So I get the square root of 16 equals 4. The square root of 16 is 4. So I have 4 equals 4. So x equals 19 is a good answer for number 2. It does work. All right, let's check out number 3 now. Number 3 says the square root of 2x plus 6 equals 3. Maybe you want to pause your video on this one and see if you can take a shot at this one on your own. So remember, we're trying to get rid of anything that's on the outside of the radical first. So I'm going to subtract 6 as my first step. So I have the square root of 2x equals negative 3. Now, this might be a place where you would want to say, wait a second, this seems strange. I can't have the square root of something equal a negative number, right? Now, if you see this and you see a square root equals a negative number, you're probably going to know right away that this is going to tell me that I have a no solution, right? But as you're in your process of solving, you know, you might miss that here and there because we get so into our game of like, I gotta solve, that sometimes you miss those little details, like the square root of anything can never equal a negative number. So let's just say that you kept going, right? If you were gonna keep going, you would want to square both sides. So I'm just going to put it right in the same thing right underneath. Pretend like you kept going, and you would say, okay, well, my radical's all alone, so I'm going to square both sides. So square root and squared cancel out. I get 2x equals negative 3 squared. Negative times a negative is a positive. Positive 9. And then I divide both sides by 2, and I get x equals 9/2. Now, fractions aren't bad. You can have a fraction in a radical. Fraction for an answer doesn't mean that it's a wrong answer. But let's check what happens when we plug that fraction back in. Okay, so here's our checking for extraneous solutions. So my original equation would be the square root of 2x, so the square root of 2 times x, which is 9/2, right? 9 over 2. Plus 6 is on the outside, is supposed to equal 3. All right, now 2 times 9/2, these two cancel out, so I'll have the square root of 9 plus 6 on the outside equals 3. The square root of 9 is 3, plus 6 is supposed to equal 3. 3 plus 6 gives me 9. 9 does not equal 3. No way. So that means that 9 over 2 is not a solution. Now, we don't write our answer is not extraneous solutions. Our answer, we would say, is no solution. Oops. Okay, so we would write our answer as no solution since the one answer we got doesn't actually work. But this answer that we had, this 9/2, we call this an extraneous solution. It was an answer that we got that didn't work. Okay, so don't write your answer as extraneous solution. That doesn't make any sense. Your answer is no solution. But that number that we got originally, we call an extraneous solution, a number that doesn't work. So here's the deal. If you're showing your work, you're solving, and you catch that radical equals a negative number, what? No way. You can stop. You can say no solution. Boom, done. Nothing else you need to do. So right up there at that highlighted step, If you caught that, you could say no solution and be completely done with your work. That's it. But if you don't catch that, if you actually get an answer, then our process where we have to check every single answer, your process should catch and be your safety net and make sure that you don't write that answer down when it doesn't work. All right, two more problems for us to do. Okay, this next one, square root of 3x minus 2 equals the square root of x plus 6. Now this one's different because I have a square root on both sides. I notice everything is inside the radical on the left. Everything is inside the radical on the right. Nothing's on the outside. So what I need to do is get rid of those radicals. I can't move anything, can't combine anything. Everything is locked into those radicals. So my first step is to just square both sides to get rid of those radicals so I can start combining some things. Square root and squared cancel, so I'll be left with 3x minus 2 on the left. Squared and squared cancel on the right, so I'll left with x plus 6 on the right. Radical's gone. Now it's just a pretty easy equation, right? I'm going to move all my variables to the left, so I get 2x minus 2 equals 6. I'm going to add 2 to both sides. 2x equals 8. And I'm going to divide both sides by 2, so I get x equals 4. Still need to check for those extraneous solutions, right? Here's my check. I'm going to take my original equation, 3 times 4, right? Plugging in that x, minus 2 is inside the first radical on the left. On the radical on the right, I will have 4 plus 6 on the inside. Okay, and again, don't solve here, just do your order of operations. So let's see, I'm going to do 3 times 4 on the left, so I'll get radical of 12 minus 2. I'm going to do 4 plus 6 on the right, so I'll have radical 10 on the right. I have 12 minus 2 on the left, so I have square root of 10 on the left equals the square root of 10 on the right. Now, I don't need to get rid of that radical. I noticed that the left equals the right. So that works. That's all I need to do. Okay? Some people think you have to keep going until the radical is gone. That's not true. You just have to keep going until the left equals the right or the left does not equal the right. So having a radical in your checked answer is okay. So x equals 4 did work on this one. We were good to go. All right, last one here. See if you can do this one. All right, so the first thing I see is I have this plus 5 on the outside. I also have this 3 on the outside, but think about as you're solving, you always want to get rid of those loose ones first, or do your order of operations in opposite order, right? So I'm going to do my adding and subtracting and undo those before I undo my multiplying. So I'm going to subtract 5 from both sides here. I'm going to have 3 radical x minus 1 equals negative 3. Well, maybe you're noticing a negative, but don't say anything yet. We got to get rid of this 3 in the front of the radical, right? The radical is not by itself yet. This is 3 times radical x minus 1. So in order to get rid of this 3, because it's 3 times radical x minus 1, I would want to divide both sides by 3. So I will have the square root of x minus 1 equals negative 1. Oh, wee-oo. Hopefully some warning bells are going off in your head. Boom, right here. If you caught that, this should be a no solution, right? A square root can never equal a negative number. But let's say you missed it. All right, I didn't see that, and I kept solving. So here we go. Square root of x minus 1 equals negative 1. Square both sides to get rid of my radical now. So then I have x minus 1 equals negative 1 times negative 1 is positive 1. Add 1 to both sides, and I end up with x equals 2. All right, now if we're in our process, we would then check our solution, right? So if I check my solution, I have 3 radical 2 minus 1 is on the inside of the radical, plus 5 is on the outside, and this is supposed to equal 2. Well, I would start by doing inside the radical. So I'll have 3 radical, 2 minus 1 is 1, plus 5 equals 2. 3, let's see, radical 1, that's really just 3 times 1. 3 times 1 is 3, plus 5 equals 2. 3 plus 5 is 8, and 8 does not equal 2. So this one is officially no solution. Whether you solved it all the way out or you caught it way back at that highlighted step where you got a radical equals a negative number, boom, no solution, right? And that answer that we had gotten, that x equals 2, that's what we would call the extraneous solution, but the answer should be no solution. All right, we did a lot there today. So just remember when you're solving radical equations, make sure the radical is by itself, nothing on the outside added or subtracted, before you square both sides, right? Square both sides to get rid of a radical. After you get an answer, make sure you check to make sure your answer works. Plug your answer into the original equation and then use order of operations to see if both sides are equal to each other. Any answer that doesn't work is called an extraneous solution, but the answer to your equation should say no solution. All right, good luck solving.